Well, good afternoon. Thank you very much for being here. I know it's a beautiful day outside. It's a gorgeous space, but I mean, perhaps being outside is also a temptation right now. So thank you for being here. Um, uh, I'm actually celebrating today that the book got the third medal. Kathleen talked about the first one we got at the Biennale in Mexico City. Then the book got the medal best publication at Biennale in Mexico. And last night, my publisher wrote me a text message. I was in a dinner saying, you got the medal to best publication in the Pan American Biennale in Ecuador in Quito. So we are very happy to yeah, thank you. And it's interesting because the book is, as you will see, is about this work, and pretty much is about historic buildings. And biennales are meant to celebrate contemporary pieces of architecture, contemporary work. It's given by the profession, it's not by scholars. So I find rewarding that this research is making an impact, not only in the academic level, but also in the profession as well. So with that, what I'm going to present today is just talk about these beautiful 16th century churches that exist in Mexico, in the southern region of Mexico. And I'm going to try to communicate, I'm going to try to show you how digital technologies help me to learn new things about buildings, about those buildings, and help me to explain the buildings in a very unique way, I will say. So pretty much what we see, what we look at building digital technologies, the most common one perhaps regarding historic buildings or relationship with historic buildings is what we call the point clouds, right? Point clouds now can be obtained from different tools, such as laser scanner. What we see here is a laser scanner point cloud. And also nowadays, photogrammetry, it's really working very well in terms of producing useful point clouds, right? It's a technology that is rapidly advancing, is moving forward really quick. Just as an anecdote, my colleagues in Spain bought a laser scanner, which, case was about the size of this table over here, really difficult to transport, spent a lot of money on it. 2 years later, it was almost outdated, right? Not really useful that much anymore. The software is also rapidly improving. And it seems that what we are leaning towards is towards photogrammetry as a really useful tool for working with this. But these type of technologies produce this very enticing, right, type of imagery that is always very attractive, right? When we can see this image, we can visit or at least visualize places within the structures that will be very difficult to visualize or to have access to otherwise, or with with traditional survey methods. So this really opens a wide range of possibilities for us to interpret buildings and so forth. So the buildings that I'm talking about are located in the southern port region of Mexico. This is Texas. We are somewhere around here, the center of Texas, right? So this is the state of Oaxaca. If we zoom in, we see that these three buildings that I have been studying are located in the northern west part of Oaxaca, very close to what the state of Puebla is. The road to Mexico City actually goes through those churches. And they are very special because of several reasons, right? The first one is this one, San Juan Bautista Coixtlahuaca, where you approach the building is just a very undeveloped, we'll say, type of landscape. Approach the building, you see a very tall 16th century church, but once you walk in, you see this magnificent set of ribbed vaults. The same thing happens with Santo Domingo Yanguitlan. This is a recent photograph as well. As you move through the road, all of a sudden you see this really, really tall church that used to be the tallest building in the Americas in the 16th century, which also, as you enter in the church, you see this wonderful set of ribbed vaults making up the roof of this church. And then the very unique building, which is the open chapel of the Poscolula, which is a building that was meant to accommodate the Christian ceremony, but on an open space. And the reason why the open space was necessary is because indigenous people used to have their religious ceremonies at the open space. So this is early 16th century. These three buildings that we are talking about here were built between 1550s and 1580s, 1590s, before the large epidemic that happened in this area of Mexico that killed about 2/3 of the population by the end of the 16th century. So, and the same thing, as you approach the building, you see that there is a very large ribbed vault using these Gothic methods of construction. So, situating these buildings within their context, right, historic context, the first questions that emerge are, well, how were they built? We know that the labor was mainly indigenous people, right? How did the transfer of building technology happen? And how is it that these indigenous people learned to make this type of buildings? They were not familiar with this type of building technology at all, right? So there are some hints that we can find within history, right, such as these illustrations in the Florentino Codex that explain, in some extent, the activities that took place within this type of endeavors, within this type of building construction. There is also a vast number of studies that explain how these buildings were built mostly in Europe and explain how they worked, different types of interpretation, different types of representation that aim to put together the puzzle and understand how these people used to build these buildings. One of my favorite images here are these vaults by Leonardo da Vinci and Albrecht Dürer that pretty much show the endless number of possibilities when designing this type of structures that these master builders had at that period of time. There is actually a nomenclature for each one of the elements within the ribbed vaults, and I would like to review them so we can follow up with the presentation. The first one will be diagonal rib, which goes across the vault, right, diagonally. Tiercerons, which will be secondary ribs that will subdivide each one of the liarns over here. The keystone being that central keystone that will be placed once the construction supposedly is completed. Bosses that will articulate different ribs, right? Tierceron ribs or these ridge ribs over here. Former arches will be supported by walls, and transversal arches will cross perpendicularly across the nave, similarly to what these trusses are doing up here on the space. And then the tasse de charge will be the spring point where all the ribs emerge together. And it's really beautiful illustration of this hand, right, showing how each one of the fingers pretty much belongs to each one of these ribs. So the perpianos or transversal arches, right, need to be a little bit thicker because they support a couple of bolts, right? The middle finger will be the diagonal, it's also a little bit thicker, right? And then this little finger will be the former arch, and doesn't have to be as thick because it's supported by walls, right? Structurally, also, they have some meaning. So looking back to also to 16th century manuscripts, we see that the master builders had a method of how they designed these buildings. We see in this drawing by Hernán Ruiz, a document located in the Polytechnic University of Madrid, that they had a system to identify the main elements within the rift walls and then be able to design them and to build them within those cathedrals or those other buildings, right? The same thing we can see here in this drawing by Alonso de Vandelvira, that also tries to explain graphically what are the steps, the methods that a master builder will need to follow in order to make sure that this three-dimensional puzzle made of stone will be possible to construct. And more contemporary studies that have shown that there are different types of patterns that exist between different types of structures across Europe, right? And how they actually can be identified as different schools of thought, different schools of construction methods. So based on all this foundational knowledge, is that we went and did the 3D scanning, right? Okay, so what is the first thing that we needed to do was pretty much to identify the buildings and the elements that we wanted to work with pretty much in the interior of the churches, and use this scanner that it was showing over here. You see the scanner laser ray reading the targets over here, right? And pretty much in a couple of days per church, collect all the information necessary. And what can we do with that point cloud information? Well, we can do different things, right? As I mentioned before, you can do visualization, but also you can think about cutting through the point cloud, zooming in, as I mentioned before, reaching to those areas of the building that otherwise will be very difficult to reach without any major scaffolding or something, right? Have a graphic type of information that will be useful for analysis. So the work that we embraced was pretty much on the three-dimensional, on the three-dimensional and two-dimensional features of these point clouds, making sections through them, cutting through them, looking at them from different perspectives, using different types of software, so we could actually recreate and understand what were the main principles, design principles, and also constructive principles that drove these structures. So these are type of the images that we will be looking at. So we were really aware that what we were dealing with was, and I say we because I've always worked with students, right, on this project, that we were dealing with a set of rift walls that were following the same building methods as those used in the Gothic period in Europe, right? It was a technology that was transported, was imported or exported from Europe to the Americas, especially to Mexico, and that they have to follow a specific rules, a specific design parameters, a specific constraints. So they work structurally, but also they form the space that they are required to form, right? So what are those constraints? What are those design rules that were applied here? And within all this process, right, we use different types of visualization methods. For instance, what we are seeing in this photograph is what is usually called rendering farm, right? So took over the entire computer lab for an entire week during the summer, using the computers at their maximum capacity in order to create short clips so you could see those animations that I just showed to you, right? Engaging this process of modeling and visualizing and editing and so forth. Parallel to this process, we also thought, well, why don't we start also using 3D printers, right? How can 3D printing can help us to understand better these structures, but also explain them in such a way that other people who are not precisely experts can understand what the characteristics of the buildings are and why they are significant, right? So this is the idea is that 3D printing is just like we print a paper, right? You hit print and then the thing comes out, but it's actually a very meticulous, laborious process that involves a lot of work, a lot of trial and error, and then, well, the assembly of these models. These are large models that also requires some work. So those are the different types of work that we embraced, or the goals that we had. I have to confess that making these 3D models with 3D printers wasn't originally the plan. The animation weren't either, but as we were developing the work, we saw the potential of this type of visualization systems, and we took advantage of them and developed them, right? So, but in terms of the research findings, what we see is that looking at the buildings from each one of the buildings, we find similarities and we find differences. For instance, here in San Juan Bautista, Coixtlahuaca, right, we see the configuration of the monastery with the large church, right? This large church, as I mentioned, with these excellent ribbed vaults that follow a square plan and so forth. But what matters here is, and this is the type of discussion that the specialists engage, is, okay, how were they designed? And what we learned here is that by looking at the point cloud, having a very clear orthographic projection, seeing them purely in plan, is that we can recreate what were the geometric steps or constructions that were necessary to identify the layout of the ribs in plan. For instance, here we see that the very first step after drawing the diagonals, right, and the ridge ribs over here was to draw a triangle within that square, and that defines the path of those tierceron ribs. And this operation is repeated 4 times, 1 per side of the square, right? And then the last question, right, remaining is where do we find the diameter, the center, the radius for this circle right at the center, right? So the next step will be to draw another triangle connecting the boss that connects the 2 tiercerons, and using this one of the sides of the squares as a base, and that will identify the point where you can see the radius of this internal circle, and therefore having the entire drawing of the vault completed. This needs to be translated into the 3-dimensional spectrum, right? It needs to be translated into elevation, and then learning from cutting through this point cloud is that we could recreate and figure out the radii that were used for each one of the arches, and come to interesting conclusions. For instance, in this case, that the vault, there are 2 schools of thought. One of them will be that the vault is a preconceived shape that the master builder tries to achieve, right? First, he says, okay, this is my shape. At this period of time will be usually a sphere, right? And I'm going to figure out how I draw all these all these ribs, so I achieve this spherical surface on the space forming the vault. The other one, which is more ancient, which comes from the Gothic period, says we are going to draw every single rib individually, and the overall shape of the vault is just a consequence, right? The overall geometry is pretty much a result of how each one of those ribs were drawn. Well, turns out that this vault follows this Gothic mode of thinking, right? Each one of these ribs do not respond to an overall geometry, but respond to a very individual set of operations that at the end form this vault with this very flat center within that configuration. So these are other types of visualization where we see the point cloud compared with these lines, in figuring out if the actual hypothesis of these principles of design are correct, right? And then all of those are pretty much tested, right? Be able to actually reproduce what we would call orthographic projections, understand how this was actually built on space, and be able to visualize this vault from the constructive perspective, right? So we are seeing that each one, how individual pieces form these arches, and how these arches form the vault itself, and how, as I mentioned here, you are going to see the pieces right at the center, right, forming a pretty much horizontal ring, right? And then the keystone comes in and understand also the stability, principles of forest stability for this type of structure. The second one, which is Janguitlan, right? The Church of Janguitlan, mentioned the tallest building, 16th century, really tall vaults. We see that, again, 4 vaults on a square plan that follow exactly the same design. So taking one as the model, we start to understand how they were designed in plan, right? Starting by a equilateral triangle. Something that identifies this vault, that is unique to this vault, is that of this set of vaults, is that they have 2 tiercerons, right? So they have the diagonal ribs, but they have 2 tiercerons, which is not common, especially if you start comparing this type of vaults with other vaults of similar span and the square plan shape. But nevertheless, the designer decided to use double tiercerons, and so therefore the task is to identify where those initial operations in plan were performed, how they were done, and then identify what are the sequence of steps that the designer had to do in order to give a form in plan to this vault. The second one will be very similar, using the point cloud. Start looking at each one of those arches, right? They have distortions, deformations. What we are facing right now in class, for instance, I teach a class on building documentation, is this contrast between what was made, that is very handcrafted, right? It's actually indigenous people who had never built this before crafting these vaults, so of course they are not perfect, right? And then using the digital tools that require this excessive amount of precision, right? Everything is to the millimeter, to the 32nd of an inch. So trying to negotiate with these tolerances, with these imperfections, if you call them that way. So there is some sense of how these were designed. So what you see here is just a series of drawings that project the point cloud in plan and then in section, seeing them vertically and horizontally, right? in order to identify the radii that govern all the arches within the vault. And what is interesting about this vault is that the master builder here had a Renaissance school, came from a Renaissance school, meaning that what he was thinking is to form a spherical surface, and all the arches that form the ribs of the vault actually are designed so what we see up there is a segment of a sphere, right? So it's the opposite to what the previous vault, right? That one was a result of individual operations. This is a preconceived vault, and the master builder does whatever is necessary to achieve that form. So the same process of verifying, understanding, and then seeing how, well, through this process, how this vault performs. And this is not the vault that is supposed to be there. So I'm going to just jump this slide. But the point is that the three-dimensional animation helps to explain that better, right? And then finally, the open chapel of the Postcolula, which is a unique building in many respects. First of all, because open chapels were usually built for temporary purposes, right? It's wild indigenous people accept to walk into the churches. It's wild the indigenous people transform into the Catholic religion. Is wild we build the actual church many times. But in this case, the open chapel is built specifically for being an open chapel, to to stay as an open chapel, and to be a monument for the town. So this is the building itself. Look at the church, right? The church is really modest if we actually compare it with the presence that the open chapel has. This is a monumental building. It's really tall. In fact, a person will be about this tall over here, right? It's almost difficult to show. And the idea is that the altar will be here, the priest will be here celebrating the ceremony, and the indigenous people will be here attending the ceremony, right? But also it's very unique because the vault, right, that was what has been surprising for many of my colleagues around the world, is that it's actually based on an hexagonal plan. There are no many precedents of a vault of this nature to be built into a hexagonal plan. So that pretty much determines many of the aspects that pretty much show the way in which this was designed. So based on this hexagon, right, is that there is a series of operations based on the triangles that happen within the hexagon, right, that start to identify the path and the geometry for each one of the ribs. We see that this vault also has a series of ribs that are called warped ribs because they have, we'll say, double curvature, right? Not only the curvature of the surface of the arch itself, but also are traveling within that surface and therefore have this double curvature. And each one of these steps is going to be used to identify where those warped ribs will take place. Then a series of operations similarly to those that we did before, right, in order to understand how those arches were actually built. And in this case, understanding that because of the hexagonal nature of this plan, the consequences of the arches form what we will call a dome, right? And a dome will be pretty much like half of an sphere, half of an orange, right, that has been sectioned by these hexagon sides. Working through the process of understanding if those calculations, hypotheses, based on the average of the information that we obtain from the point cloud are somehow precise, and then moving into a much more detailed set of operations. This is the vault of Yang-Whitlan, but I mean the idea is that all these vaults are governed by this notion of making smaller pieces that have to have the very precise shape to be, on one hand, to fit within the arches, but also to be structurally stable. So think about this as a three-dimensional puzzle that is about 50,000 kilograms, about 50,000 tons, all made with stone. And then, well, identifying the overall geometry pretty much brings the second layer of the questions, which is pretty much how each one of those pieces were cut. So following a similar procedure, what we see here on green is the point cloud, right? And you can barely distinguish in this on the screen right now, but there are some lines of different color, and what is pretty much those lines represent are sections through each one of those pieces, right? That will help us to identify the profiling of the pieces themselves, and then start to reconstruct them, right? And understand what the actual solutions were. These are pieces that are, I would say, are almost like sculptures, right? They are really, really large. When we visit a church, we look up there and they look so small, but in fact, a stone from the quarry will have to be about 4 feet by 4 feet by 4 feet, or 5 by 5 by 5. I mean, there are large pieces of stone that have been carved out in order to form these connections, right? The connections where the ribs converge. And each one of those solutions is important to recognize, because what we can learn is, one, what school of thought they belong to; second, how they used to solve this type of architectural and constructive problems, and third, also see if there is any influence of the indigenous people in the manufacture of this type of pieces, right? And then using the visualization that offers this, that this three-dimensional modeling offers, in order to explain with a little bit more detail how is it that each one of those pieces were carved, right? What are the procedures that a master mason, right, who is chiseling the stone, need to follow in order to create these nodes where all these different ribs converge, right? And what I find compelling about this type of representation is that not only is interesting for, or is of interest for the specialist, but also for other type of public who are not precisely experts on this, but are understanding how is this actually built, right? So they have different shapes, and the process is quite interesting. At the end, well, we have a catalog, right, of pieces for each one of the vaults, right? Compare sizes, right? Compare methods, compare solutions, and then translate those into a much more traditional methods of depiction, such as these orthographic projections, which have been used since the 18th century with descriptive geometry, right? And visualizing the different pieces, like the task, the charge, right? Thinking about how they are carved and how they come all together. So all the crucial elements that form the structure, right? So there are several conclusions that can be drawn from this work. Perhaps the most important one is that if we look at historic documents, we find that there is almost or pretty much no information about who built, who designed these buildings, and where they came from, et cetera, et cetera. That information is non-existent, it's lost. It's early 16th century, so we have to understand that very little information was being compiled at the time. So there have been several speculations about these buildings by architectural historians who have said that because they are so close together and because they use rift walls, they were designed by the same architect or the same master builder, who very likely was a friar, was a priest from the Dominican order, who were the order that actually led the efforts to construct these buildings at that time. But when we start looking at buildings with much more precision, we see that, in fact, there is no possibility that there is only one designer and only one master builder coordinating the efforts for the three churches. There were three different master builders within them, right? So the differences are substantial. Who were they? We don't know exactly, but we know at least that they come from different schools of thought. Then, as part of the efforts of disseminating this work, is that there is an exhibition that has been traveling through Mexico, was here last summer, and pretty much what the exhibition tries to show is that using this three-dimensional 3D printing technology to show, well, how is it that these were built, right? This is just this is just a time lapse that we took of making actually those models, right? So those models, when we printed them in the 3D printer, they were made by individual pieces, right? And then assembling the models. The idea is that because the exhibition travels, that each one of those members of the vaults can be dismantled, can be stored in a suitcase and jump on the plane and go to the next place, which pretty much means that I have to go every time the exhibition is assembled because I am the only one who actually knows how to put together this, right? And putting together an IKEA type of manual would be kind of difficult. So, but it gives you the sense of the scale of the models, right, and also the time and the effort that it takes to actually put them together. But also when I go to different institutions, students participate, right? They help me to put these models together, and they actually learn about the principles of the construction and stability that govern this type of structures, right? So these are images of one of the venues where the exhibition was placed. In fact, the very first one, right? So it's photography and also each one of the keystones, the bosses are printed individually at a larger scale, so people can actually compare sizes. We can see them here. So just to wrap it up, right, I think that I'm going to state the obvious, but what we see is that digital technologies can help to look at historic buildings from a different perspective, right? The visualization techniques can be a platform to explain the buildings or the structures of this nature and appreciate the significance of these buildings, right? Through the exhibition, I saw a lot of people saying, look, this is the church where my father was born. I didn't know it was that important or it was built this way or anything like that, right? The enticing natures of this imagery, right, that is created by these methods of visualization can help to educate other people. I have seen how younger generations see themselves identified with the work because it's similar to what they are working with nowadays on their computers, on their own work, but is reflected on historic buildings. It's important to identify what the purpose of using these technologies is, right? I have seen a number of times use, I will say, an abuse of these laser scanning, digital animations that, yeah, they help to understand the buildings from a very unique perspective, but they don't go farther about that animation, right? Which pretty much, I believe it's important to ask, okay, why is it that we want this information? How are we going to use it? And what the final purpose of that is. I was talking about the precision, right, versus the handcraft nature of the structures, being able to negotiate those, it's important. And they will open new fields of research, right, looking at the buildings from different perspectives. They can help to understand better the stability of the structures, of historic buildings, to look at to evaluate the state of conservation, and therefore be able to achieve a much more precise intervention strategy that will be more compatible with the building, and will help to preserve the integrity of the building themselves, especially when they need some type of intervention, right? So as I mentioned, there is a publication as well that came out from National University of Mexico. I mentioned to you, have won a couple of awards already. And also there is a website, www.mixtecstockcutting.com, where you can find all these animations and a little bit more of the information that was obtained through this project. And with that, I finish with the presentation. Thank you very much for listening. Thank you. I think that we have time for questions, yes? Yep. Well, they can be, structural advantages will be that was common practice to have what is called a compression ring, right? So that pretty much, those circles closer to the keystone will help to alleviate the stress that a keystone will receive, because they pretty much are collecting some of the forces before the keystone gets to collect those forces. So it's pretty much reinforcement, but also it's a way of decorating the vaults with a structural component. Yeah. Well, for instance, what I was talking about, right? The finding is, okay, there is no way these were designed by the same architect, right? But then the question is, who that people were, right? For instance, another type of question that I can imagine emerging from this technology is how, now that, for instance, we work with parametric design, right, or parametric tools. If there is a set of parameters or patterns that govern the design of these structures, is there a possibility to recreate those through purely computing effort, right? And what will be the variables, or what will be, how can do this reverse engineering through the exercise of feeding parameters or equations to computers and what they will produce, right? Also, what I was trying to do, there are some nuances in some of the volts that are very difficult to discern from this very straightforward perspective. They will need a little bit further study. So the other question is, for instance, that I'm trying to solve is if this parametric approach can help to develop the best approximation to the original design or to the curvature that one of the ribs has without this method of trial and error, that's the one we did, actually drawing it. But how can we automatize this type of operations? That will be another one, right? In terms of visualization, I think what we did here is kind of very straightforward, but I see that there are many other potential ways of visualizing this work using this three-dimensional information that we obtain from digital files, from digital information. Yeah. Yeah. Yes, it is an area prone to earthquakes. It's actually very active in terms of earthquakes. And these buildings are extremely heavy, very, very heavy. So, in fact, when you have an oscillating earthquake, right, that moves horizontally, the buildings move very little. And what happens most of the time is that in this oscillation, the walls separate from each other, and then the arch pieces kind of go down a little bit, right? They dropped a little bit, but then the walls close back together and they trap them, right? So, in other words, you can see each one of these arches as a series of individual pieces that when an earthquake comes, they move like, all together. So that's why they have been able to withstand several earthquakes throughout the history. I mean, they have been up for 400 years or so. So they work differently, but that's pretty much how they manage to disperse the energy that an earthquake makes to the building itself. Yeah. Well, the archival information, as I mentioned, is kind of scarce. What we, for instance, found recently, or knew that it was found recently, is in the town of Tepozcolula. They found the accounting book of the mayor of the town, and they have information from the 16th century. So there might be possible that will give some hints of who those people were and what they were, right? How they did it, how much it cost, and all of that. I haven't had a chance to actually dig into that information yet. It's fairly recent. But your question is how archival information can transform this work, and also or how this can influence right? I think the way in which this information can, I just imagine that for instance, talking about the author, right? We're talking about who was the person who designed this, right? So by finding that these are actually three different people, I think can direct research into, looking at trying to find who those three were, right? And try to figure that out, perhaps, right? Instead of the assumption for many, many years was that, no, it was one single person, right? They are so close together, churches. They use the same building systems. There's no way that we could, it was kind of an assumption already, right? So I see that a big shift on that regard, right? What I think it's still part of the questions is how the indigenous people impact the actual construction. I mean, we know that they were the labor, they knew where the stone was, they had the skills to carve the stone the way they carved it. But if there is actually a difference between these structures and those structures that were built in Europe, for instance, based on the way they were built, that's still a question to be answered. I don't know if that totally answers the question, but it's some of the questions that might emerge. Yeah. Mm-hmm. Yeah. Well, I mean, what we can recollect, especially from what was happening in Spain at the time, is that the involvement of friars on construction of buildings, especially using this technology, was very little. There were master builders that were hired and knew the methods, had the skills to actually build this, right? If looking at that type of information, then one can assume that once they start building these buildings in the American continent, those master builders had to travel to Mexico. It's known that some of the friars had some knowledge in architecture and construction, but there was limited, right? And if we see that in Spain, what was happening is that they were actually hiring master builders to do the work. One could believe that there was. Now, there are a lot of churches where you can see that the actual friars were leading the design, the construction, and they are much, much simpler, right? Very, very modest in terms of the actual construction. In order to do something like this, the master builder should have been trained and should have had some specific knowledge, and therefore not being a friar. Yeah. 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 Yes, there is. I mean, there are. You can find towns in the state of Oaxaca where people are still carving stone and do that for living. Yeah, restoration. Yeah, they mostly do restoration. If they do new structures, they will be doing just balconies or fountains or stuff by nature, but they will never be building like large structures such as this one. It's a lot of time, right? And therefore, it's pricey, it's expensive. It was already pricey and expensive at the point, at the time. They are Dominicans are called out by the king, well, by the church in general, because they were building these very fancy, very, very expensive buildings in that region, right? And some some other friars from other orders were criticizing Dominicans for being for expending so much money, for being so, I would say, perhaps pretentious at that time. Yeah. Yes, sorry. Yes. Yeah, and well, you know this, but mid 20th century, the government of Mexico takes over all the properties of the church. So therefore, all these properties are owned by the state, by federal government. And therefore, it's responsibility of the federal government to maintain them. They have a priest who actually inhabits the space, who, is still offering ceremonies, mass, and all of that. But the church, and they can lead efforts to collect money for conservation, all of that, but they pretty much rely on federal government funds to do the maintenance of the buildings. Or mayor interventions, I would say, as well. Well, if there are no more questions, thank you very much. Again, thank you.